Hey stats class, let's look at one more example of some problems from the 8.3 homework set hypothesis test about means. So if you read this, what it basically is saying is, given the information that we have, this sample of 200 students, do we have evidence that the students that complete their core curriculum score higher than 23 on the math portion of the exam? So the null hypothesis is going to be the mean equals, all right, we're going to always have equality in the null, the 23. And then the alternate is the mean is greater than that 23, because that would mean that they're ready, right? If they score 23 exactly, that would also be technically okay, but 23 or better would imply that they are ready, that they score that higher than that amount based on the sample evidence. All right, what are the requirements? The requirements, we have a bell curve and a randomly sampled distribution. So, I'm sorry, a random sample to create that distribution. So we have a sample that's larger than 30. All right, it doesn't mention anything that the population is normally distributed. So the sample would need to be higher than 30 because we're not told that the population is normally distributed, and the population is, or the sample is higher than 30 here. All right, the test scores are independent of one another. We do have independence between test scores because they're not cheating off of each other, so they're going to be independent of each other's one score to the next. And it says directly right there, in a random sample. So the sample was taken randomly, so we can assume all three of the requirements for a bell curve are met and the t-distribution can be used. Alright, so let's run the test. I just wanted to know the test statistics, so that means run the test. So I'm going to go to stat. This is a hypothesis test about a mean, so that's going to be a t-test. Do we have data or stats? We have just the stats. Alright, 23 is our cutoff, so we're going to put a 23 there. Our sample mean was 23.5 with a standard deviation of 3.5. Alright, our sample size was 200, and we want to do greater than because, again, we want to see if core curriculum improves us beyond that 23. So there's our test statistic, that 2.02, and then the next thing it's going to ask for is the critical value. Alright, because this is a right-tailed test, not a two-tailed test. If it was two-tailed, we'd have to do this, but this is a right-tailed test, so it's going to be B. And we're going to use the inverse t to find this critical value. So I'm going to do second distribution. There's inverse t. The area, because we're just in the right tail, the area to the right is going to be, so this is a 0.1 is the level of significance, again, in a right-tailed test like we have here. That's the area in the right tail. We need the area in the left tail. So this would be 1 minus this 0.1, be 0.9. So that's my area in the left tail. Remember, inverse t, just like inverse norm, takes in area to the left. Degrees of freedom is 199. It's one less than the sample size. So I'll paste that in there. So there is my critical t value. Again, it's not t alpha over 2. It's right tail test, so it's t alpha. 2 decimal places would be 1.29. Alright, and then a conclusion based on the results of this, again, hypothesis test. I'm going to just go back and run it again to get all the values back on the screen. It'll keep the last hypothesis test you ran. So when I had to conduct that critical t value in the middle of it, it kind of interrupted things. But there's my p value. It's 0.02, and I'm comparing that to the alpha of 0.1. Right, 0.02 is less than 0.1, so I will reject that null hypothesis. Right, that null hypothesis, go back up, what we set up was the mean is 23. We have sufficient evidence to conclude the population mean is greater than 23. Again, that's the alternate hypothesis there. We have evidence to conclude, and then it's just stating the alternate hypothesis from that part of the sentence on. Alright, so that is a t-test from start to finish, set up, critical values, test statistic, p-values, conclusions.